In this video, we're going to cover sections 5.1 through 5.4, and we're going to introduce the ideas of probability. So probability is used when we have a situation that deals with what's called random phenomena, which means that we can't predict the individual outcomes, but we can have some understanding of what happens in the long run. So for example, when flipping a coin, I don't know if it's going to land heads up or tails up, but I do know that 50% of the time it will land heads up and 50% of the time will be tails up. We have what's called a trial, which in the coin flipping would be one flip of a coin, and the outcomes are what could possibly happen. So for coin flipping, the outcomes would be it could land heads up or tails up. And the sample space is a list of all the possible outcomes. So for example, if we're rolling a die, the possible outcomes are the numbers 1 through 6. If it's your standard regular die, so I would write 1, 2, 3, 4, 5, 6. And when we write sample space, we put it in a brace, which is the name for that squiggly bracket. You'll see it on your keyboard. If we let A be the event that an even number is rolled, then our sample space includes only the even numbers. So the even numbers that we could get on a die are 2, 4, and 6. And if we let B be the event that a number less than 3 is rolled, then our sample space would be all the numbers on a die that are less than 3. That wouldn't include 3, that would just include 1 and 2. So probability is long-run relative frequency. And we also have this idea of independence, which we often see in situations that use probability. It means that the outcome of one trial doesn't influence or change the outcome of another. So when you're rolling a die, what you get on the first roll doesn't affect what you get on the second roll, and so we say that that's independent. Coin flipping is also independent. If you get heads on your first flip, then your probability of getting heads on the second flip is still 50%. And we have what's called the law of large numbers, which basically means that as your number of, in this case, this is looking at flips, as your number of flips of the coin increases, then the total number of heads or tails that you get, this is looking at heads, your total number of heads will approach 50%. So at first, like you might flip the coin 5 times and get 3 heads, that would be 60%. But as you keep flipping the coin more and more and more, then your total number of heads is going to approach 50% of the total number of flips. Empirical probability is the probability that's the result of an experiment. So for example, if I take a poll of 1,000 voters and find that 513 support a bond issue, estimate the probability that a randomly chosen voter in the city supports the bond issue. Well, I have 513 who support out of 1,000 total, so it would be 513 divided by 1,000, which is 0.153. A common misconception about probability is that things aren't due to occur if they haven't occurred in a while. So if I flip a coin and get heads up 5 times in a row, my probability of getting heads up on the next flip is still 50%. Tails is not due just because it hasn't landed that way in a while. So we also have, in addition to empirical probability, we have what's called theoretical probability, which is when we calculate probability based on the mathematics of the situation, not based on an experiment. So for example, if we're rolling a die and recording which number is rolled, we want to find the probability of rolling an even number. Well, I know that there are 3 even numbers on the die, 2, 4, and 6, and I know that there are 6 total numbers on the die, 1, 2, 3, 4, 5, 6. So the probability of rolling an even number is 3/6, which I can simplify to 1/2. I can also write it as a decimal, 0.5 or 50%. Pay attention to the way that my stat lab wants you to record numbers in the problem. If I want to calculate the probability of rolling a number less than 3, there are 2 numbers less than 3, 1 and 2, on the die out of 6 total numbers. So that probability would be 2/6 or 1/3, or as a decimal, 0.333. Next, we're going to go through some probability rules. The first rule is that the probability of something that will never occur is 0. The probability of something that will definitely occur is 1. And all probability values must be between 0 and 1, including 0 and 1. So for example, which cannot be probability values? 0 can be a probability value. 2 cannot be. 1 can be. 3/5 is between 0 and 1, so that can be. Probability values cannot be negative, so -1 doesn't work. And 5/3 is bigger than 1, so that also cannot be a probability value. 0.0123, that is okay to be a probability value. So those three numbers cannot be probability values. The second rule is that the probability of the set of all possible outcomes must be 1. So if I add up the probability of every outcome in the sample space, then that has to equal 1. So for this example, we're looking at a spinner on a child's game. Is it possible that the probability of landing on red is 0.4, probability of landing on blue is 0.1, green is 0.2, and yellow is 0.2? So to check this, what I need to do is add up all these probabilities, and if it's possible, they should add to 1 because there's no other possible outcome besides those 4 colors. But if I add all these numbers, then I find that the sum is 0.9. So that means that is not possible because they do not add to 1. So there's 2 things that need to be true for a set of probability values. The first is that all of your values need to be between 0 and 1. So you can't have negatives and you can't have numbers greater than 1. And the second thing is that all of the probabilities must add to equal exactly 1. Rule 3 is the complement rule, which states that the probability that an event occurs is 1 minus the probability that it doesn't occur. So something either occurs or it doesn't, and those 2 probabilities add to 1. The probability that something doesn't occur is sometimes called the complement, and you'll see maybe this notation A with the C, that means the complement. And this is where this rule is helpful. We're going to use it in problems. The probability of at least one thing happening equals 1 minus the probability that none of them happens. And so here's an example. Lee's Lights sells lighting fixtures. They record the behavior of 1,000 customers entering the store for 1 week. Of those 300 make purchases, what is the probability that a customer doesn't make a purchase? So this is pretty easy. Probability that you make a purchase, we can calculate that. That's 300 over 1,000, which is 0.3. So the probability that you don't make a purchase is 1 minus 0.3, which would be 0.7. Rule 4 is the multiplication rule. So when we have 2 independent events, probability that both A and B occur is the product, which means multiply, of the probabilities of the 2 events. So P of A and B equals P of A times P of B. And this only works if A and B are independent. So for example, we roll a fair die twice. What is the probability of getting a 3 for the first roll and an odd number for the second roll? Probability of getting a 3, there's 1 3 on the die out of 6 numbers, so that's 1/6. Probability of getting an odd number, 1 and 3 and 5 are all odd numbers on the die. So that's 3 out of 6. So the probability of getting 3 on the first and odd on the second would be 1/6 times 3/6. And if I remember how to multiply fractions here, 3 times 1 is 3, 6 times 6 is 36, 3 over 36, or 1/12. Question 2, if we can assume that customers behave independently, so in other words, what one customer, whether they purchase or don't purchase, doesn't affect whether another customer makes a purchase or doesn't, what is the probability that the next two customers entering Lee Lights both make purchase? So the probability of one person making a purchase, going back up here, is 0.3 or 30%. So the probability of somebody making a purchase is 30%. Multiply that by the probability of the second person making a purchase, and that gives me 0.09 or 9%. So the first 0.3 represents customer 1, and the second 0.3 represents customer 2. Rule 5, the addition rule. If we have disjoint events, they have no outcomes in common, which means that they cannot both happen at the same time. And this is an image that shows that they're disjoint, there are no outcomes in common. So one can happen or the other, but they can't both happen. So first we're going to look at deciding whether the following events are disjoint. When you draw one card from a deck, A equals drawing a king and B equals drawing a heart. Now, can those both happen at the same time? Yes. So they're not disjoint because you could draw the King of Hearts. When you draw one card from a deck, if A is drawing a king and B is drawing a 7, those would be disjoint because you can't draw a card that is both a king and a 7 at the same time. If it's a king, it can't be a 7. And we can use the addition rule, which says that we can add probabilities of disjoint events to get the probability that either event occurs. So multiplying we use in situations where we have the word and. Go back up here. A probability of A and B occurring. We use addition when we have problems that involve the word or. Probability of A or B occurring. So the first question is, if we roll a dice once, what is the probability of rolling an even number or a 3? So we know that 3 is not an even number, so we can't have both a number that is even and a 3. So they are disjoint events. So probability of even or 3 would be probability of even plus probability of rolling a 3. Probability of rolling an even number is 3/6, and probability of rolling a 3 is 1/6. So if I add those together, I get 4/6 or 2/3. If we don't know whether the events are disjoint or if they're not disjoint, then we would use the general addition rule. And this didn't come up very well in the PDF file, but this is a minus sign here. So probability of A or B occurring, we would add probability of A plus probability of B and subtract the probability that they both occur. And the reason that we do that is because the events that occur in both have been counted twice. They've been counted in probability of A happening and they've been counted in probability of B happening. So because they've been counted twice, we want to subtract those so that we get back to having them only counted once. So for example, if we roll a die once, what is the probability of rolling an odd number or a number greater than 2? So probability of rolling an odd number is 3/6, and probability of rolling a number greater than 2, that would be the numbers 3, 4, 5, and 6, and so that's 4/6. But what is the probability that a number is odd and greater than 2? Well, there are two such numbers, 3 and 5. So the probability of rolling a number that is odd and greater than 2 is 2/6. So probability of rolling odd or greater than 2 is 3/6 plus 4/6 minus 2/6, which equals 5/6. And if you think about it, that should make sense because that would essentially be every number on the die except for the number 2 itself. So 2 is the only number that is not odd or greater than 2, so I have a 1/6 chance of not getting this, and so the chance of getting it is 5/6. And for this example, this is getting your car inspected. The event of your car passing inspection is independent of your friend's cars, and 75% of cars pass inspection. So the probability that your car passes inspection is also 0.75 or 75%. The probability that your car doesn't pass inspection would be 1 minus 0.75. This is using the complement rule. So 0.25, 25%. What is the probability that you and your friend's cars pass inspection? Now your probability is 75%, and your friend's probability is 75%. So the probability of you and your friend passing, that would be multiply. And so I would multiply those two numbers. And if I multiply that, I get 0.5625. So the 0.75 here, the first one represents you, your car, and the second one represents your friend. What is the probability that neither car passes inspection? So your probability of not passing is 0.25, and your friend's car's probability of not passing is 0.25. So this is you, this is your friend, and if you multiply, you find that that probability is 0.0625, or 6.25%. And lastly, the probability that at least one of two cars passes. Well, at least one is the complement of the probability that no cars pass. So if at least one car passes, that could mean that your car passes, your friend's car passes, or that both of your cars pass. The only thing it doesn't mean is that neither car passes. So this is the example of P at least 1 equals 1 minus P none. And we calculated the probability that neither car passes up here. So it would be 1 minus 0.0625, which would be 0.9375 or 93.75%.